In this video, we are going to talk about how to calculate energy. That's going to be potential energy and kinetic energy. Each one of them has different equations, so we'll talk about it when we get to those particular problems. A brick is sitting on a platform that is 13 meters high. It has a mass of 0.1 kilograms. What is the brick's potential energy? So here it's asking us to solve for potential energy, and I have the formula up in the top right corner. I just want to make sure that we talk about this real quick. So let me write down everything we need about this formula. So potential energy equals mass times gravity times height. Okay? And as you can see from our formula above, potential energy is abbreviated as PE. And anytime we're talking about units of energy are going to be joules. And we talked about also that in the work video. Mass, which is abbreviated as M, the unit for mass here is going to be kilograms. Gravity, you're going to assume gravity on Earth, okay? Unless specifically told otherwise, or unless you're calculating gravity, you're going to assume 9.8 meters per second squared. And then lastly, we have height, which is abbreviated H, and this is in meters. So we need to make sure that we have all these units appropriate to use this formula. So let's line up our variables here. It's asking us to solve for potential energy. It gives us a height of 13 meters. Now be very careful. Don't get yourself confused. This M is, don't plug it in over here for this. That's not correct, okay guys? That's 13 meters. Meters is a type of height. So be very careful when you're doing this. Next, we have a mass, and that's going to be our M of 0.15 kilograms. And then gravity. It doesn't list gravity on this problem. You need to know that, unless you're told specifically otherwise, gravity is 9.8 meters per second squared. All of these are in the correct units to use this formula. So now we plug in our values. So 0.15 kilograms times gravity, which is 9.8 meters per second squared, times 13 meters. So for this right here, we're going to put this values in our calculator, and we get 19.11. Now what are our units going to be? So we have kilograms times meter. Well, that's kilogram times meter squared divided by second squared. None of our units cancels out here, okay? So we're left with all of them. Now, if you previously have watched the work video, if you watched that before you watched this one, you might be thinking, well, hold on, Dr. Forbes, you told me that 1 joule equals a Newton meter, but a Newton meter is not really in there. Well, actually, it kind of is. It's just hidden a little bit. So a Newton equals a kilogram times meter per second squared. Well, that's found right here, okay? We just have this one extra meter we have to account for, and that's fine because that's represented right here. So, or you could just simply say, if you don't understand that, that's fine. We can also just add on to our definition of a joule. And 1 joule also equals 1 kilogram times meter squared divided by second squared. So our final answer here is actually 19.11 joules. For this problem, a roller coaster cart is at the top of a 41.7 meter hill and has a mass of 2,380 kilograms. What is the cart's potential energy? So again, it's asking us to solve for potential energy. And we need to know mass, gravity, and height. It gives us a mass of 2,380 kilograms and a height of 41.7 meters. And then again, our gravity is not listed in the problem, but we know it's 9.8 meters per second squared. All of our units are what they need to be in, so we just need to multiply all of the values out here. So 2,380 kilograms, 9.8 meters per second squared, and 41.7 meters. Once we put all these values in our calculator, we get quite a large number. So let me write it down here. And if you want to, you can put the 0.8 on there. So we almost have 1,000,000 joules. And guys, that's fine. Sometimes these numbers are going to be very large, okay? Especially if we're dealing with something this massive. It takes a lot of energy to move a roller coaster cart, okay? So that's fine if you get a really big number, especially if you're dealing with a large mass and a higher place off the ground. For our next problem, you throw a baseball with a mass of 1.25 kilograms. The ball leaves your hand with a speed of 7 meters per second. What is the kinetic energy of the ball? So here it's talking about kinetic energy. So again, I have that formula on the top right, but let's review this formula really quick. So kinetic energy, and remember kinetic energy is energy of motion, where potential energy is when something is still, so it's not moving, or stored energy, I guess is the better term for it, is 1/2 mass times velocity squared. In terms of our units here, kinetic energy is abbreviated KE, and these are measured in units of joules because that's what energy is measured in. We have a 1/2 value. We have mass, which is abbreviated as an M, and it needs to be in kilograms. Our velocity is abbreviated V, and it needs to be in meters per second. Now, the most important thing that I can tell you, over half the time, if not 75% of the time, if someone solves one of these problems wrong, it's because they forgot to square, it's because they forgot to square this velocity, okay? So make sure, this is very, very important, that you are always squaring your velocity number. And remember your order of operations in terms to whether you square first or you multiply and so forth. So let's go ahead and jump into this problem. So kinetic energy, that's what's asking us to solve for, equals mass, or not equals, but we have mass and velocity as variables. The mass is 1.25 kilograms. We have a speed of 7 meters per second. So kinetic energy equals 1/2 mv squared. We plug in these values, 1/2 of 1.25 kilograms times 7.0 meters per second squared. Always square your velocity first. So 7 squared is just 49. And remember, we also have to square our units. So I forgot to write the units down there, meter per second. So 7 squared, this would end up being 49 meters squared second squared. The next thing I do is multiply the two terms and then I take half. However, it doesn't really matter in a sense of those order of operations. So putting this in the calculator, we get a value of 30.6. And again, our units are kilograms times meters squared over second squared, which is the exact same thing as 30.6 joules. For our last problem, what is the kinetic energy of a 0.275 kilogram snowball that is rolling at 3.6 meters per second? So it wants to know the kinetic energy, and we need our mass and velocity variables. Our mass is 0.275 kilograms. Our velocity is 3.6 meters per second. All of those are in the correct units. So we just need to plug in the variables. So 1/2 times 0.275 kilograms times 3.6 meters per second. And again, right here where we're rewriting this is where people always mess up. They forget to put this square up there. Make sure you are squaring the velocity. That is very important. So right now, if you want to, go ahead and pause the video, put this in your calculator, and see if you get the same answer that I get. So I have 1/2 times 0.275 kilograms times the square of 3.6, which I got 12.96, and that's going to be meters second squared second. Putting the remaining values in our calculator, I got 1.78, and then our unit for kinetic energy is going to be joules.